All right, we're going to talk arguments. Okay, so how do I know if the argument that I'm making is valid and actually proving the point that I want it to prove, or how do I know if I'm just speaking nonsense? So we're going to talk about symbolic arguments. Now, again, we are just doing a really fast, we've been doing logic for 2 weeks. So our arguments are just going to be nice, relaxed, simple. Maybe we'll have 2 simple statements. Maybe we'll have 3 simple statements. But in real life, arguments are bigger than that. Okay, I understand, and you can perform logic on them, but we're going to stick with this just because we are getting used to this subject. Okay, so here is my example. This is the one that I'm going to do, and I'm going to do all the parts of. So if you have any question about this, let me know. So here is the argument. Okay, it says if the figure has 3 sides, then it's a triangle. The second statement is the figure has 3 sides. Then we see this. We see the word therefore. The word therefore tells you that that is the conclusion to the argument. So what we want to know is, do the 2 statements above that, do they logically imply that that conclusion has to be the result? Now, these 2 statements right above the conclusion, if the figure has 3 sides, then it's a triangle, and then the figure has 3 sides, these are called the premises of the argument. So if I use those words, that's what I'm referring to. You've got your premises, and then you've got your conclusion. That's the different aspects of the argument. So anytime we're doing this in this class, we are going to go through these steps. The first thing we're going to do is something very familiar. We've done this a bunch of times in different contexts. We are gonna first take this argument and write it symbolically. So I'm going to define my simple statements. I've got 2 of them in this argument, P and Q. So what do you want to call P? Okay, we're just reading in order. It really doesn't matter as far as whether you get this problem right or wrong on the test or on the homework, but we're going to just say, okay, the figure has 3 sides. That's the first thing I see. So P is the figure has 3 sides. Well, then what is left to be statement Q? Perfect, great job. If I lose anybody at any point, please let me know. My example is going to be very similar to your examples, just changing statements, changing connectives, but the process is identical. Okay, so now step 2, we are going to write our argument symbolically. So first premise is, if the figure has 3 sides, then it's a triangle. What is that symbolically? Okay, P, I heard you say P, I heard you say arrow, and then what's on the other side of the arrow? Q, right. Statement P is the figure has 3 sides, the arrow then, Q is it's a triangle. Perfection, great job. Everybody tracking with me? Okay, I know this is difficult stuff. I don't want to just race through it, so let me know. The second premise is the figure has 3 sides. So what is that? That's just P. In math and in logic, the word therefore is used quite a bit. So math people are lazy, so they have symbols for everything. So the symbol for therefore is 3 dots in the form of a triangle. So when you see 3 dots in the form of a triangle, that is the word therefore. That's indicating your conclusion is coming up. What is my conclusion? What's symbolically? Therefore what? It's triangle Q. Great, nice, relaxed argument right there. Okay. So again, that's something that I think we're used to. We've done a lot of writing things symbolically. Again, that's why we took the whole class period in section 1 and we were bored to death because we just kept writing things in words. But that's the payoff is we're used to it now and it's not too big of a deal. This is the new bit. Okay, this is the new bit. So the new bit here is I've got to form the argument. You don't have to write this on any problems you do. I'm just writing this on the first one because this is the new bit of information for us. Okay, we're forming the argument right here. And here's how you form the argument. This is the general way you're going to do it. I'm going to take my premises, and I want to know, do they imply my conclusion? That's always the general form. You're going to take your premises, you're going to group them together. I'm going to show you how to do that in just a minute. And then you put an arrow, because it's going to be an if-then statement, and you want to know, do these premises, if these things are true, does that have to imply the conclusion? So the way that looks for our argument right here is like this. I'm going to put a bracket. My first premise is if P, then Q. So I'm going to put P arrow Q here in some parentheses. Then I'm going to put an and. You always use an and, okay, because these are the premises. First premise and then the second premise. Okay, so then and P. Does everyone see where I got these things from? This is the important part. Okay, don't miss this. This is the only new information in this section is forming the argument. Yeah. Why did we put what? Around the P arrow Q? So the question, in case you didn't hear, is why did I put parentheses around this? Because now I'm using this and I've got to separate. This is the first premise and this is the second premise. Okay, so these parentheses tell me that these two things go together. If you had three premises, I don't think that occurs in our homework, but if it does, if you have three premises, then you would do and you would do the next one in parentheses. And the reason I didn't use parentheses around this P is because it's just one thing. Okay, so it's not anything bigger. Great question. And then my arrow, and then my conclusion. My conclusion is Q. That's my argument. My argument is formed. No, the three dots are just when you write the argument symbolically. Yeah. Yeah, you're always going to use some big brackets because we'll use the little parentheses for each individual premise when they're grouped together. And the only reason you use different shapes is just so you know which ones go together. That's the only reason. You could use rounded parentheses here, but then sometimes it gets confusing to know which ones go with what. All right, so then all that remains is now you do a truth table. And here's how you make your conclusion. If you get a tautology here, that's a review word. Does anyone remember what a tautology is? Okay, that's okay. I know we talked about it at the end of one of the sections last time. Tautology is everything's true. Okay, if you get a tautology, then what you have, a tautology means you have a valid argument. Okay, if you don't have a tautology, if you have any F's at all, it's not valid. Okay, so if you have any F's at all, that means the argument is invalid. That's how you make your conclusion. So if my premises, then my conclusion. So I'm going to do my truth table. This part, hopefully, we've done like a billion truth tables in this class. So hopefully this part feels familiar to you and not intimidating. So here I go. I'm just going to work with my premises first. I'm going to do a column for if P then Q. Again, I've tried to drill into your mind all of the basic truth table facts so that when you get here and you're using them, that this isn't a big deal. So the conditional statement we've said over and over is false when it's true then false. That's the only condition. So true then true is true. True then false is false. False then true is true. False then false is true. I don't have any squigglies I need. I don't have anything really else. So I'm going to finish off my premises. I'm going to do the if P, then Q, and then and P. Well, you'll have some in some of them, but yeah, it looks kind of bare without any squigglies and stuff like that. You're right. Okay, so I'm going to take the if P, then Q. I'm just going to put a dot above that. I'm going to put a dot above the P. And again, this is the basic truth table fact that I've tried to repeat over and over, that an and statement is true only when both are true. So I've got true here, so true. I've got true here, so that one's false. False here, false. And then last but not least, false here, false. So on this one, we're about done. We're ready to make our conclusion here because I've got my premises. This is right here. I'm just going to write the word premises so you know what we've done. You don't have to write this when you do your own problems. Just trying to show you the components as we go. My conclusion is not there's no squiggly, there's no and, there's no or, there's nothing on the conclusion. So I'm ready to finish. So I'm going to do this. You don't have to write the whole thing. I'll show you what I would write, but for this first one, I'm writing the whole thing just so you know. Honestly, if you want to shorten things down, here's what I would normally write, what I'll write next time. I just write the brackets without anything in them, just to symbolize. The brackets mean my premises. Okay, just saves me some ink. No, this is cute. Oh, you got better eyes than me. Yes. Sorry, everybody. I can't talk and write. Sometimes I get away with it, but I didn't get away with it right there. So I apologize for any confusion that caused. Yeah, that's supposed to be a P. I've told you in the past that I always draw an arrow. So I'm going to draw an arrow from my premises to the conclusion, which is Q. Because order matters with my conditional statement. It's the only one that order does matter. So here we go. I've got true, then true. That's good. I've got false, then false. That's good. I've got false, then true. That's good. And then false, then false. That's good. So notice I've got a tautology. What this means is no matter what the truth value of the original statements was, I always am speaking truth. So that means that my premises always produce my conclusion, and that's why this is a valid argument right here. All true, valid. If there's even one F, invalid. All right, so we've got plenty of time to do our other two examples, and then we'll be at a great stopping point for today. So example 2, I'm going to leave my example right here. I mean, you've got it written down, but I'm going to leave it right here on the screen for you. I want you to turn your attention to example 2. You know what? Let's do this in phases so we're all on the same page. First thing, define your simple statements and write that argument symbolically in example 2, and then go ahead and stop, and we'll make sure we all have the same thing going. No negation, yes. So the question, in case you didn't hear it, is when you write down your simple statements, always leave out the negation. Leave out any nots or no's or anything. Great question. All right, so let's see how you did with this. Again, if you have a question, ask it. I'm just going to go in the order I'm reading the statement. So the first one says, if it snows. Okay, so I'm going to stop there. If it snows. I committed a typo here. I'm sorry. I should have the word then in there. I left that out. I apologize. If it snows, then I will not do my homework. So I hope maybe you figured that out, or maybe you were just confused. So my apologies. So if it snows, then I will not do my homework. So I will do my homework is the second one. Or I do my homework, or did the particular format of the verb is not super important. Okay, everybody tracking with me? Sorry about the typo. Okay, here we go. The first statement starts with the word if. So I have my arrow. So if it snows is P, and then I will not do my homework is what? Squiggly Q. I need the squiggly now. The next premise is I did my homework. So that's just Q, a different verb form of Q. Therefore, it did not snow. So that is what? Squiggly P. Great job. Okay, so there's the argument written out in symbols. Now what I would like you to do, just over here on the side, I would like you to form the argument. Okay, again, I'm going to write this down to give you a little hint. The form of the argument is you take your premises and you link them together, and then the conclusion. Yes. Yes. When you link the premises together, it's always an and statement. You can get started if you feel super confident. I'm just going to wait 30 more seconds, give anybody else still working a moment, and then we'll form this. So the first premise is if P, then squiggly Q. Notice I'm putting that in parentheses just to let everybody know those two things go together. And the second premise is Q. I don't need parentheses because there's nothing going with that. And then my conclusion on this one is squiggly P. So that's the premise, or excuse me, that's the argument that you should have formed. Again, that's the new thing for today, is forming that argument. If you have a question about that, ask it. If not, let's finish this up. Go ahead and do your truth table. And we'll determine if this is valid or invalid. All right, I'm going to get started on the truth table. Keep working if you're working. Ask whatever questions you have. I'm going to start my truth table with the premises and get that fully formed, and then I'll worry about the squiggly P for the conclusion later. So in my premises, I notice I need a squiggly Q. So we got the answer to our prayers from the last problem. Now we got some squigglies going on. So squiggly Q is going to be false, true, false, true. So inside the parentheses, I've got if P, then squiggly Q. Conditional statement is false only when you have true then false. So here we go. True then false right off the bat. False. True then true. False then false is true. And false then true is true. So my first column, my first premise, the P then squiggly Q is false, true, true, true. Okay, I've got the parentheses. There's nothing to do. This is not a squiggly. It's not linked together with anything else. So now what I'm going to do is I'm just going to do the P, then squiggly Q, and Q. So I'm going to put a little dot. I've got the P and squiggly Q right here, then the Q right here, just to keep myself focused. So those are the two things. I'm joining together with the and. Ands are true when both are true. That's the only time. So true and false is false. False and true is false. True and true is the true one. False and true is false. We're almost done? Yes, what's up?
Why are you going left to right? Right to left,
On the first one, I went right to left at the very end for the conditional statement because the Q column was way over here. And so I draw the little arrow to remind myself that the order matters for a conditional statement. But for any other statement, the order does not matter. So you only have to pay attention to the order when you have a conditional statement. So down here, I went left to right with this one because the P was in this column and the squiggly Q. So they were in this order, those two right there. That's why I went. So the column just determines in what order I read these things in. Okay, so great question. And so before I can do my whole argument, I do need to take care of the squiggly P now. If you did the squiggly P earlier, that's fine. Just make note of your position. Draw your little arrow to make sure that you're going in the correct order for your end here. So P is TTFF, so squiggly P is just the reverse, FFTT. And now since my squiggly P column is here and my premises are right here to form the final argument, so those brackets represent my premises, then squiggly P. I'm going to go in this order just because of where they are. Again, just to repeat, if your squiggly P is over here somewhere, then your arrow is probably pointing the other direction. Okay, that's fine. So here we go. The conditional statement's true in all times except for T then F. So we've got F then F, that's true. We've got F then F, that's true. We've got T then T, that's true. And then F then T, that's true. So this again is another example of a valid argument because everything in that final column was true. All right, we got 15 minutes left. Here's what I'm going to have you do then. One more example. I'm going to give you about 5 or 6 minutes to make as much progress on this one as you can. So the 3 steps: write the argument symbolically, then form the argument with your brackets, and then do the truth table. Those are the 3 steps to doing this. So 5 or 6 minutes. If you're watching the video, I'm going to pause you just to make this a little shorter. So pause yourself, and then when you're done, press play. All right, I'm going to get started. If you're working, keep working. Check in with me, see how you're doing. So starting off, I'm going to define my simple statements. So the first statement says the grass is green or the grass is full of weeds. So statement P is going to be the grass is green. Statement Q is the grass is full of weeds. Sure, you can abbreviate. Yeah, as long as you know what's going on. The important thing is The most important thing is being able to take these words and accurately translate it into symbols. So whatever you need to do. Okay, so here we go. The first statement is grass is green or, so I'm going to circle the word or, the grass is full of weeds, so that is P or Q. The second premise is the grass is not green, so that's squiggly P. Therefore, my 3 dots that represent the word therefore, and my conclusion, the grass is full of weeds, that is Q. So now I'm going to form the argument. The argument is formed by taking my premises, which is P or Q, and joining it with and. You always use an and then my other premise is squiggly P. And I want to know, does that always produce Q? Next thing is the truth table. Okay, so we've only got 2 simple statements, so we've got 4 rows to the table. Remember, if you do one on the homework, there might be one with 3 simple statements. You'll have 8 rows, just like normal. Other than that, if there is one like that, I don't remember, but if there's one like that, the process is identical. There's nothing that changes. So here we go. In my brackets, it doesn't matter which one of these 2 things in the brackets you do first. I'm going to do the P or Q. If you do the squiggly P right here, that is fine. The order doesn't matter. So P or Q, the or is true when either one is true. So I've got true, 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 false. I'm going to do squiggly P now. P is TTFF, so squiggly P is FFTT. And now I'm going to take that and I'm going to join them together with an and. So I'm going to take the P or Q and the squiggly P. And is true only when both are true. That is the only time. So here we go. True and false, that's false. True and false, that's false. True and true is true. False and true, that's false. I don't have a squiggly, I don't have an or, I don't have anything over here, so I'm just about done. Again, I'm going to draw my arrow. If you want to repeat and write the column Q here because you like going left to right better, that is a fully great thing to do. I'm just going to draw my arrow in this direction. These are my premises. This is my conclusion column. So the conditional statement is false only under one condition, when you have true then false. So we go false then true, that is fine. False then false, that is fine. True then true, fine. False then false, fine. So I gave you another example of a valid argument just so that you'd have plenty of experience doing that.